3 says for each table below, use quadratic regression to find the equation of the parabola and give its line of symmetry, y-intercept, zeros, and vertex. So in order to use quadratic regression, I have to take the information that's given to us in the table. I'm going to take this numerical data and I'm going to plug it into my calculator. So I've started a new document already, and I'm going to add a list and spreadsheets page. Then I'm going to be very careful and type in the information. So my column A is going to represent my x values, and column B is going to represent my f of x values, which are the same as y values. So my first point is 2, 1. My second point is 3, 6. My third point is 4, 9. My next point is 5, 10. After that, we have 6, 9. After that is 7, 6. And the last one we have is 8, 1. So I like to just kind of go back through and verify that I put those in right. So I have 2, 1, 3, 6, 4, 9, 5, 10, 6, 9, 7, 6, and 8, 1. Now that I've entered my data, I'm going to add a new page. This time it's going to be the 5th choice for data and statistics. And then I'm going to scroll down to the bottom, click and add my variable for x, scroll over to the other side, scroll over to the other side, click and add my variable for y. And then we see the parabolic shape take form. And I'm going to go to Menu, Analyze, Regression. Now I'm not going to choose Show Linear because if we look at the graph, that is not a line. That is definitely a curve. So I'm going to go to Menu, Analyze, Regression, and I'm going to use quadratic regression. And it gives me y equals -1 times x squared plus 10 times x plus -15. Which is the same thing as -x squared plus 10x minus 15. And I'm going to put that in a graph. So -x squared plus 10x minus 15. Okay, and now I'm just going to change my window so that I can make sure and see everything. So I'm going to change this to 15 maybe. Ooh, not 615.67, just 15. Okay, and I'm going to come down here and I'm going to change this to -20. All right, now I'm going to go to Menu, Analyze, Analyze Conics, which is the 8th choice, and I want to know what the vertex is, which is the vertices is the plural of vertex. So I'm going to choose this one and then say, I want to know it for this graph. Boom, there it is. There's my vertex at 5, 10. And I need my line of symmetry, so I'm going to go to Menu, Analyze, Analyze Conics, Axis of Symmetry. And I'm going to select that. Okay, there's my axis of symmetry at x equals 5. Now I need the roots, so I'm going to go to Menu, Geometry, Points and Lines, Point On. I'm going to select this parabola. Be very careful about where I place my cursor. There's my intersection point. Do it again. Select the parabola. Very carefully place the cursor at the intersection point. Okay. And now the only thing I need is the y-intercept. So once again, I'm going to select this parabola and very carefully place my cursor at the intersection point. So I have my line of symmetry at x equals 5. I have my y-intercept at 0, -15. I have my roots at 1.84. 8.16. And I have my vertex at 510. So here we go. We had, after using quadratic regression on this data for this first one, we had f of x equaled negative x squared plus 10x minus 15, and I got that from using quadratic regression. The line of symmetry was x equals 5. The y-intercept was 0, negative 15. The roots were 1.840 and 8.160, and the vertex was located at 510. By the way, we can see the vertex right here because there's some symmetry. We have a 9 and a 9, a 6 and a 6, a 1 and a 1. So that point that's in the middle of the symmetry is the vertex, and the x value of the vertex is the same as the equation of the line of symmetry because the vertex is on the line of symmetry. All right, let's look at the next one. All right, so this is going to be the second one. So I'm going to add a new page. Actually, on this one, I'm not just going to add a new page. I'm going to add a whole new document. No, not going to save the unsaved document because I need to add a list and spreadsheet. And if my x and y values are already taken, I won't be able to use them again. So there's my x and y, and I have negative 6, 5, negative 5, 0, negative 4, negative 3, negative 3, negative 4, negative 2, negative 3, negative 1, 0, and 0, 5. And like to double check, make sure I put that stuff in right. Negative 6, 5, negative 5, 0, negative 4, negative 3, negative 3, negative 4, negative 2, negative 3, negative 1, 0, and 0, 5. Okay, now I'm going to add a page for data and statistics. And I'm going to scroll down to the bottom, click and add my x, scroll over to the left, click and add my y, and I can see the parabolic shape take form. So I'm going to go to Menu, Analyze, Regression, Show Quadratic. And now I'm going to write that down. So I have f of x equals 1 times x squared plus 6 times x plus 5. So I'm going to add a new page for a graph and have x squared plus 6x plus 5. And I can see all of the key attributes here, so I don't really need to do a whole lot of rearranging, but I will anyway. Move this out of the way. Okay. So I'm going to go to Menu, Analyze, Analyze Conics for the vertex first. Oh, and the vertex of this parabola. All right. It's kind of hard to see what that says because it's overlapping with the y-axis. All right, there we go. Now I'm going to go to Menu, Analyze, Analyze Conic for the axis of symmetry, which is the same as the x variable of the vertex. Since this is the first thing that's asked for, I'm going to have it be first. The next thing that are asked for is the y-intercept. So I'm going to go to Menu, Geometry, Points and Lines, Point On. I want to point on this parabola, and I want it to be very carefully placed where the parabola intersects with the y-axis, which is at the point 0, 5. And hopefully, you've noticed that the y-intercept of 5 is the same thing as this value right here in the standard form. Now I just need my roots, and I've already got the vertex, so I'm going to go to Menu, Geometry, Points and Lines, Point On, select the parabola, and very carefully place my cursor at the intersection point. Click. Come over here, select the parabola, and very carefully place my cursor at the intersection point. Click. All right, there we have it. So I'm going to come back over here. My line of symmetry was x equals -3. My y-intercept as an ordered pair was 0, 5. My roots as ordered pairs were -5, 0, and -1, 0. And the vertex as an ordered pair was -3, -4. And if you came over here, you could see the vertex was at -3, -4 because there's a pattern. -3 this side, -3 this side. 0, 0, 5, 5. And one more. Going to open a new document. No, I'm not going to save the old. Going to add a page for lists and spreadsheets. This is going to be X. This is going to be Y. I'm going to type in the information. -5, 18. -4, 3. -3, -6. -2, -9. -1, -6. 0, 3, and 1, 18. Now I'm just going to go through here and make sure that I have entered all of that information right. -5, 18, -4, 3, -3, -6, -2, -9, -1, -6, 0, 3, and 1, 18. Now I'm going to add a page for data and statistics. Scroll to the bottom, click and select X. Scroll to the left, click and select Y. And now the parabolic shape has taken form, so I'm going to go to Menu, Analyze, Regression, Show Quadratic. So we got 3x squared plus 12x plus 3. X squared plus 12x plus 3. Add a graph. 3x squared plus 12x plus 3. I'm going to do all that same analyzing, except right now I can't see the vertex. So I'm actually going to change this bottom value down here to -15. All right. So now I can see all of the key attributes. So the first thing I want is to analyze the graph, analyze conics, and I want the axis of symmetry for this parabola. And the axis of symmetry for this parabola is the line x equals -2. Next, I want the y-intercept. So I'm going to go to Menu, Geometry, Points and Lines, Point On, select this parabola, and very carefully place the cursor at the intersection point of the y-axis and the parabola. So we get 0, 3. Now I need the zeros, which is just another way to say the x-intercepts. Menu, Geometry, Points and Lines, Point On, this parabola, right here. this parabola right here. And the last thing I need is to analyze the conic for the vertex, this parabola. Okay, so I have all the information that I need for the problem. My line of symmetry is x equals -2. My y-intercept as an ordered pair is 0, 3. My roots as ordered pairs are -3.730 and 0.2680. And the vertex is at -2, -9. -2 for the x of the vertex is the same as the line of symmetry because the vertex is on the line of symmetry, and we hopefully recognize that this was the vertex because of the symmetry around it. -6, -6, 3, 3, 18, 18.